Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to talk about some of the important terms that you often encounter in statistical courses. And we are going to start our discussion with the idea of population. So here we have population, and it is defined as a collection of all elements that you are interested to study. So all these elements here can be anything really. It can be people, places, companies, animals, things. Okay, so this is the collection of all elements that you would like to study. And if let's say you take a sample out of this population, so here is your sample. Okay, so sample is basically a subset of a population. So this is the elements chosen to be in a particular sample, and it is just a subset or a part of a population. And the reason why we often study sample is because in most cases it is impossible to study the whole population, and because of that we resort to studying a sample right here. And sample in general I think can be divided into two categories, broadly speaking. Yeah, so the first one is what we call the random sample, and perhaps this one is sample that is non-random. So when we talk about a random sample, basically we have the element of probability in place. So basically in random sample, we have probability in place. So the way we select our sample is based on some sort of probability. For example, in random sample, the simplest method of random sampling, I would say, is simple random sampling. So in this simple random sampling, basically all the element in the population has the same probability of being selected to be included in the sample. Okay, so that's the idea. And usually when you talk about random sample, we can generate random numbers through random table, some sort of random numbers from a table, or you can use a computer to generate random numbers in order to help you to find or to select elements that can be included in your sample. So that's the idea of random sample. Now next we are going to talk about non-random sample. So in non-random sample, basically there is no element of probability. For example, in non-random sample, we can consider what is known as convenience random sampling. Now this sort of random sampling here is quite common and is seen applied in many studies. Let me give you a few examples. Well, let's say we select our sample to be people that go to the mall. So imagine that you are standing at the entrance of the mall and you've been handing out survey form to people that goes into the mall. So this is an example of convenience sampling, because it is convenient for you to just go to the mall and distribute the questionnaire, for example. Or maybe you select your sample based on patients that come to the clinic in the first 6 months. So this is also a type of convenience sampling. Okay, right, now I would like to stress an important point here when we come to talk about random sampling. When we have a random sampling, then it becomes the basis of us, it becomes the basis for doing inferential statistics. So what is inferential statistics? Basically, we are going to use our sample. So here is the sample. We are going to use sample in order to predict or generalize the result of our population. So we use sample in order to predict, or we want to generalize to this population. Okay, generalize the results to population. Basically, to put it simply, it is saying that, hey, if we see our sample behave in this way, then we can say that the population also will behave similarly. So that's the idea of generalizing the results of your sample to the whole population. All right, so let's see, we have covered the idea of population, sample, random sample, convenience sample, which falls into the non-random category, and inferential statistics. Now we're going to talk about, well, the remaining ideas. Okay, so let's move on. So now, well, again, let's say we have population. So here is our population. Again, what is population? It is just the collection of all elements that you are interested to study. All right, but you know, for some reasons, practical reasons, usually we can't study the whole elements in the population. So what we do is we take the sample out of it. Okay, so we study the sample instead of the whole population. So this could be your sample. And the reasons could be because of it is more cost effective to study the sample, or it might be because you don't have enough time to study the whole population. So that's why you take a sample out of it. Okay. Right. Now, when you study samples, okay, when you have samples, let's say you are able to use all the elements in the sample here. So let's say you are able to take all these results here and you do some sort of measurement. For example, you measure something. Okay, you do measurement here. For example, you calculate the mean out of this sample, and the mean here is, well, usually see this mathematical symbol. We denote x bar. We use x bar to denote the mean of the sample. And then this is known as statistic. So the mean sample is an example of statistic. Similarly, if you use all the data you have here to calculate, for example, the standard deviation, and in mathematical notation or mathematical symbol, it is usually denoted as S. So these are examples of statistics. Statistics are the measurement that you get from the sample. Now, on the other hand, if you are able to take, let's imagine, or let's think that, let's say you are, able to collect all the elements in the population and you get some sort of measurement from those elements. Let's say you calculate the mean. The mean is usually denoted as mu. Just to denote the difference here from population and sample. So when the mean is calculated based on the whole population, it is usually denoted by mu. And similarly, for example, if you calculate the standard deviation from the whole elements in the population, and then it will be denoted as sigma, and these are examples of parameters. So basically, to differentiate between these two terms here, parameters and statistics, it is we can simply say that measurement for parameters come from the elements in the population, and the measurement of statistics here comes from elements in the sample. Now, if we talk more about parameters, well, parameters are usually, parameters are usually unknown. Okay, usually unknown because it is usually impossible for us to consider all the elements in the population. So because of that, we can't calculate or we can't obtain mu. So because of that, mu is unknown, or parameters in this case are unknown. And so what happens in practice is that we shall use statistics to estimate the unknown parameters. So we use statistic to estimate the unknown parameters. Okay. Right, next, what we have next is, well, based on the sample here, we can ask all sorts of questions that will then generate a random variable. So what is a random variable? So random variables are just measurements that we get from a random experiment, So the keyword here is random or random sampling. Okay, so that's why the name is random variable. We have all sorts of data that comes from random experiment or random sampling. Now, our random variables can be broadly categorized as discrete, and it can be continuous. Okay, continuous. Let me just write it down properly. Okay, so it will be continuous. Right, so what is a discrete random variable? So for example, if let's say your sample consists of a number of people, and therefore you can ask, for example, how many children do you have? How many children? So this is an example of a discrete random variable because the answers that these people will give to you will be random. For example, some might say I have 1 children, I have no children. So the results that you will get is in the form of 0, 1, 2, so something like that. And clearly this is a discrete random variable because the nature of it is it can be easily counted, and it can only assume some sort of finite number in some sort of interval. So you can see that how many children here is considered as discrete random variable. So the same thing if you ask how many cars do you have to these people, to the sample, how many cars? 1, 2, 3, or 0. So these are examples of discrete random variable. Now, if you ask, how tall are you? Or what's your weight? Okay, so height and weight are examples of continuous random variables because it can assume all real numbers in some interval. So it assumes all real numbers in certain interval. For example, if you talk about weight, it can have infinitely many possible values. Some people can say, well, my weight is 53.7. Some might be even more precise, 53.75. Some might say my weight is 53.0. So those kind of infinitely many possible values, possible real numbers in certain interval. Okay. All right. I think basically we have covered in general the ideas of all these terms: statistic, parameter, random variable, continuous, and discrete random variable. So I think here we have come to the end of the video, and I'll see you again in the next video. Thank you very much for watching.